First example we'll look at is using the idea of a counterexample. So 2018 question, I think, was n plus 3 all squared is bigger than n squared, where n is an element of the set of integers, was the question. And you were asked it to say, is this always true? Is it sometimes true? Or is it never true? Is what you had to look at. And the idea with this is that you just need to find one example that can disprove. So we'll look at always first. Could you think of a value for n where this doesn't work? Well, there's nothing to this other than just trying a few things. Let's go for n is minus 3. That gives you n plus 3 squared, of course, is 0, but n squared is equal to 9. So it doesn't work in the case of n minus 3. In other words, you found a counterexample. You only need one of them, so that rules always out. Go for the never one as well. N equals 3. That gives you n plus 3 all squared as equaling 36, and n squared is equaling 9. So it does work. You found a case where it does work, and so never can't be right either. So again, you found a counterexample to the idea of it never working. That's all that counterexample is. So your answer to this was sometimes only worth a couple of marks. You're going to get a mark apiece for finding each counterexample. The other bit of proof is called proof by cases, sometimes called proof by exhaustion, where you just try everything. We're going to have a look at this one. It says that prove that n squared minus 2, where n is an element of the natural numbers, is not divisible by 4. You've done quite a lot of work at GCSE on odd numbers and even numbers, etc., and it builds on that idea, you know. So it's quite a simple thing to do this. So have a look at the first case of n being odd. As I say, this is called proof by cases. So we'll look at the n is odd case, and you can do it with words. You know, it's the sort of thing that happens at GCSE. At GCSE, they might just sort of say, if n is odd, what can you say about n squared minus 2? So pick it up from GCSE. It implies, if n is odd, it implies that n squared is odd. And if you don't know that, just try an example in your head. You know, 3 squared, 9, oh right, oh yeah, it's always going to be odd. You could prove it, but we don't need to here. And then also just go a bit further, it implies that what happens if you get an odd number and you take away an even number, you get an odd number. And if you're not sure about those things, just try a few in your mind and think, oh yeah, that's true. Now, obviously, if you've got an odd number, it can't be divisible by 4. Anything that's divisible by 4 is a multiple of 4. It must be even. So that's finished. You don't have to say anything else other than that. And then you've got the other case when n is even. What does that mean? Now then, I think in this case what might be easier is just to express n as 2m. There must be some m where m is a natural number. So n could equal 2m. If you wanted to, you could say n is equal to 2m. What happens when you square that? Well, you get 4m squared. So when you say n squared minus 2, the full expression, you end up with that. What's nice about this one is that you're saying that this term is in the 4 times table, and if you take away 2, it's not going to be in the 4 times table, and that's sufficient just to get an expression of this format to say that your number is not in the 4 times table. It can't be, because this bit is in the 4 times table. Take away 2, it's no longer in the 4 times table. You're not taken away enough. So it's not divisible by 4, and that's the end of the story. So again, this would be like a 4 marker. This is quite a well-known question, by the way. This would be a 4 marker. You get 2 marks apiece for each of these little bits that you're saying. Just see if you can do the same thing with something similar. So maybe pause the video and have a go at this one. So we've got prove that n to the 5 plus 30, where n is a natural number, is not divisible by 32. Okay, let's do this one. So we've got n is odd is the first case. Remember, this method is called cases. And again, I'm going to do this with words. It implies that n to the 5 is odd. and that implies that n to the 5 plus 30. I've just got to break it down a little bit and just do each argument, if you like. So an odd plus an even is an odd. I suppose if you wanted to, you could write a sentence there and just say an odd plus an even is an odd, however confident you're feeling. Now you've got an odd number there, it can't be divisible by 32 like we had before. Now have a look at the case when n is even, see what happens in that case. It's useful with this part of these type of questions just to write it as 2m to the 5 plus 30 and see what you get when you get that, and that gives you 32m to the 5 plus 30. This term, of course, is in the 32 times table. It is a multiple of 32, so the entire thing can't be because you've not added enough. That's the end of it. That's the end of the proof. You've shown that you've considered all cases of what n can be and that it can't be divisible by 32. So that's the kind of thing we're expecting on AS.